Hi, so today we will be solving this problem. Given an integer array nums, return the longest strictly increasing subsequence. Okay, so we need a subsequence, means it not need to be a continuous array. So we need a subsequence which is increasing. Okay, so suppose we are at this number 10. So now we see this number, this is not greater than 10, this is also not greater, this is greater. So starting from 10 we have a subsequence of length 2, which is longest increasing. Then we can start from 9. Okay, so that's how we need to find the longest increasing subsequence. So what we can do is let's say we call a function find lis, and we pass there the current index. Okay, and the our array. Okay, so this function will return us the longest subsequence. Okay, so let's pass the index. This will be index, this will be nums array. So if our index becomes greater than or equal to our array's length, then we can return 0, that we have traversed whole array. Otherwise what we can do is we have two options. We can either consider current number as the part of our increasing subsequence, or we can skip it. So first, if we skip the current number, skipping the current number means we are increasing the index. Okay, and moving to the means we are moving to the next index without considering the current index. So second thing we can have is we can take this current index, but we can only take the current index if our current index value is greater than the previous value, means if it is it is a longest increasing subsequence. So I think we also need here is a previous value. So suppose we store the index of the previous value, which is -1 initially. So if let's call this as the previous index. So this is previous index, so it will not change if we are skipping the current value. So we will check if our previous index is -1. In that case we don't have any previous value, so we can take the current value. Okay, or if it's not if previous is not -1, then what condition we need to fulfill is our nums of previous should be okay. So our nums of index should be greater than the nums of previous. This means the our current number should be greater than the previous number which we have taken. Okay, then we can what we can do, we can consider the take the current number. So we can take maximum of 1 plus. So we are adding 1 because we have added a 1 value to our subsequence, and we can call find lis on it. Okay, and now as we have chosen the current number, so the current number becomes the previous number. So we can increase our index, and our previous value becomes the current index. Okay, and now we can pass the nums. So at the end we can return this skip. So skip, we have taken the maximum of both while taking and not taking. So let's see if this is working, then we can memorize it. Okay, okay, so it's working, so we can memorize it. So as our two variables are changing, index and previous value, we can create a 2D DP. Okay, And we can initialize our 2D dp as -1, and we can pass the dp in our function call. Okay, wait a second, we need to pass the dp. Okay, so we can check if our previous index is not -1 and our dp means we have already solved this sub problem. If it's not -1, then we can return the value at this index. Otherwise we will solve it, and after solving it for these parameters previous and index, we will store it into the dp. Okay, so let's see. Okay, we also need to pass the dp here. So let's see if this works. First I will run this. Okay, we are getting index out of bound. So in the case of -1, we are getting index out of bound. So what we can do is we can create a dp of this size, and instead of checking in this variable, we can check it here. Okay, and we can store it here in +1 index, so we can avoid this -1 check. Let's see if this works. Okay, we are getting a wrong output. Okay, we need to return here also this +1 and +1. Okay, let's submit this. Okay, it's working, but it's pretty slow. So why it's slow? Because we are solving it in n square approach. How it's n square? Because we have this much states in our dp, means n into n states we are having in our dp. So there's also a solution to this problem in n log n time, so we will discuss it in tomorrow's stream. Okay, so i think we can I think that is it for today. Thank you.